Hello dear students, we are going to discuss today on filtration and clarification. The basic objective of the present lecture is to make student aware of fundamentals of filtration in pharmaceutical sciences, mechanism involved in the filtration process, along with an overview on filter aids and filter medium. The lecture also gives theories and different type of filtration. Seeing what the filtration is, filtration may be defined as the process of separating suspended matter from liquids by forcing the liquid through a porous membrane which serves to retain the solid particles. The material collected on porous membrane is called as filter cake. When solids are present in a very low concentration, not exceeding 1% weight by volume, the process of its separation from liquid is called clarification. Clarification is generally employed when contaminating material is finally subdivided, amorphous or colloidal in nature. Difficulties in filtration are generally of two types: low rate of flow and inadequate clarification. If the nature of the solids to be filtered out is such as to form an open or porous cake, there is little difficulty in filtration and generally little trouble in obtaining satisfactory clarification. If however the solids are colloidal or gelatinous or tend to form non-porous cake, then filtration becomes difficult. With many materials, it is hard to obtain the requested degree of clarification and the rate of flow may be undesirably low. Various types of filtration include deep bed filtration, which uses packed bed of particles between 300 to 5000 micrometer in diameter and the bed height usually between 0.5 to 3 meters. Deposition of suspended solids take place within the bed by variety of particle addition and collection mechanisms. The most pertinent are sedimentation, inertia, van der Waals, diffusion, electrostatic attraction and repulsion. Within the bed, the fluid flow condition is predominantly laminar. However, the packed bed may usually contain large amount of deposited solids and need generating frequently. Cake filtration. When the solid concentration in the suspension is sufficiently high, solids will bridge over the entrance of the filter medium pores. This is cake filtration. The minimum slurry concentration required for cake filtration depends on the nature of solids and filter medium, but it is usually about 0.5% by volume. Seeing the surface filtration, it is screening action by which pores or holes of the medium prevent passage of solids. The size of the particles retained is slightly higher than the mean pore size of medium. Its efficiency is defined in terms of mean or maximum pore size. Filter aids. A filter aid is a material which serves to obtain or improve clarification or increase the rate of filtration or both. Diatomaceous silica is the most widely used type of filter aid. The fundamental function of a filter and is to provide a porous cake structure. This is built up simultaneously with the deposition or retention of the suspended particles. The particles of filter aid must form a rigid skeleton or lattice structure which is capable of enstraining the gelatinous or fine particles of unfiltered liquid and yet leaves channels in the filter cake through which the pure liquid thread of its suspended matter may pass at a rate and under such pressure differentiates as are practical economically. The filter aid particles should be such character as to remain suspended in the liquid prior to the filtration step and must be microscopic in size to provide cakes which will filter out the small particles of colloidal suspensions. The object of the filter aid is to prevent the medium from becoming blocked, to form an open porous cake, so reducing the resistance to flow of the filtrate. In addition, a filter aid must be free from objectionable impurities such as soluble salts, organic matter, coloring matter, taste or odor producing bodies, gritty particles, etc. It must also be inert or unreactive in the material using filtered. Seeing to the various application methods of filter aids, The filter aid is used by three methods. First one, body mix method. The filter aid in the concentration of 0.01 to 4% weight by volume is mixed with the main slurry to be filtered. The slurry containing the filter aid is then filtered. The second method is pre-coated method. If the pressure drop is very high, then this material is preferred. A layer of filter aid up to a suitable thickness is first formed by filtration of filter aid and then the slurry is added. The third case is the special pre-coat method. It is used in rotatory drum filter. The filter aid slurry is first filtered while the scraper knife is removed. Once the filter aid cake, that is a pre-coat of the desired thickness, is formed, the main slurry is filtered. This time the scraper knife is fitted. It scraps the cake along with the small thickness of the pre-coat. Care must be taken in the choice of the filter aid, as materials with adsorptive properties such as kaolin could remove the solutes from the filtrate. This may be done intentionally, as sugar solutions may be decolorized by the means of charcoal. Kessliger is a very successful filter aid that in 0.1% concentration added to the slurry with 20% of solids resulted in an increase in the rate of filtration of 5 times or more. Filter aids are limited to clarification processes when the solids are discarded. Now, seeing the various filter media, the filter media act as a mechanical support for the filter cake and is responsible for collection of solids. It should have the following characters, as it must be capable of delivering a clear filtrate at suitable production rate. It must withstand the mechanical stresses without rupturing or being compressed. No chemical or physical interactions with the components of the filtrate should occur. It must retain the solids without plugging at the start of filtration. Sterile filtration imposes a special requirement since the pore size must not exceed the dimension of bacteria or spores. Example of filter media commonly used are woven filters. These include a wire screening, fabrics of cotton, wool, nylon. Wire screening example, stainless steel is durable resistance to plugging and easily cleaned. Cotton is a common filter, however, nylon is a superior for pharmaceutical use. Since it is unaffected by mold, fungus or bacteria and has negligible adsorption properties. Non-woven filters. Filter paper is a common filter media since it offers controlled porosity, limited adsorption characteristic and low cost. The next is the membrane filters. These are basic tools for microfiltration useful in the preparation of sterile solution. These filters are made by casting of various esters of cellulose or from nylon, Teflon, polyvinyl chloride, etc. The filter is a thin membrane with millions of pores per square centimeter of filter surface. Going towards the porous plates, these include perforated metal or rubber plates, natural porous materials such as stone, porcelain, ceramics and sintered glass. The next we will see the various mechanism of filtration. The mechanism whereby particles are retained by filter is significant only in initial stages of filtration. Some of the mechanisms are straining. This is the simplest filtration procedure in which sieving like mechanism is used. Like sieving, the pores are smaller than the particles which are retained on the filter medium. Second one is the impingement. As the flowing fluid approaches an object such as a cylinder, the flow pattern is displaced as shown diagrammatically by the streamlines. Solids have forces would cross the streamlines and strike the cylinder. But in practice, some will follow the streamlines and will not be collected or will be re-entrained. Thus, particle between streamlines A and B will be collected, and the accumulation of solids will form a rigid, roughly triangular in section as indicated in the figure on your screen. Entanglement. If the filter medium consists of a cloth with a nap or is a porous felt, particles become entangled in the mass of fibers. Usually, the particles are smaller than the pores, so that it is possible that the impingement is involved. The fourth one is the attractive forces. In certain cases, particles may collect on the filter media as a result of attractive forces due to the electrostatic precipitation, where large potential differences are equal to remove particles from the air stream. In practice, the process may combine the various mechanisms, but the solid removal is mainly by a straining mechanism. Once the first complete layer of solid has begun to form the cake on the filter medium. Next, we are going to see the various factors influencing the filtration. Filtration is affected by characteristics of the slurry, including the properties of the liquid such as its density and viscosity, its cohesiveness, etc. The properties of the solid, for example, particle size, particle shape, particle size distribution, and the rigidity or compressibility of the solid. The proportion of solids in the slurry, when the object is to collect the solid, the liquid, or both. Whether the solids have to be washed free from the liquid or a solute. Darcy's laws correlating the rate factors are dV by dt is equal to Ka delta P upon eta into L, where V is the volume of filtrate, T is the time of filtration, K is the constant for the filter media and the filter cake, A is the area of filter medium, delta P is the pressure drop across the filter medium and filter cake, eta is the viscosity of the filtrate, and L is the thickness of the cake. The constant K represents the resistance of the filter medium and the filter cake. The resistance of the filter medium is of significance on the laboratory scale. It is relatively less important on the large scale and can usually be neglected. The magnitude of the resistance of the filter medium will change due to the early layers of solids, which may block the pores or may form bridges over the entrances to the channels. The magnitude of the resistance of the filter medium will change due to the early layers of solids, which may block the pores or may even form bridges over the entrances to the channel. For this reason, the pressure should be kept low at the start to avoid the pores plugging and increased as the cake builds up. The usual procedure is to filter at constant rate and increasing the pressure as necessary. When the normal working pressure is reached, it is maintained, hence the rate of filtration decreases as the thickness of the cake increases. When the rate is uneconomically low, filtration is stopped, the filter cake removed and the filtration restarted. The principal properties of the solid affecting the resistance of the cake are the surface area of the particles, the porosity of the cake, rigidity or compressibility of the particles. Thus, any decrease in the resistance of the cake will show as an increased value of K. So, increasing the rate of filtration, this can be done, for example, by using filter aids. Surface area of filter medium. The total volume of filtrate flowing through the filter will be proportional to the area of the filter. Hence, this rate can be increased by using larger filters, using a number of small units in parallel. In a rotatory filter, the filter cake is removed continuously, giving in the effect an infinite area for filtration. Seeing the pressure drop across the filter medium, the rate of filtration is proportional to the overall pressure drop across both the filter medium and the filter cake. The pressure drop can be achieved in number of ways: reduced pressure, gravity, centrifugal force. Seeing the reduced pressure, the pressure below the filter medium may be reduced below atmospheric pressure by connecting the filtrate receiver to a volume pump and creating a pressure differential across the filter. Advantage of reduced pressure is the safety, since if part of the equipment fails, it will collapse and not explode. Disadvantage includes reduction of pressure lowers the boiling point of liquid so that it is possible for the filtrate to boil in the receivers, causing the loss of liquid, and the vapor may be damaging to the vacuum pump. Second is the pressure. The commonest method to obtain a pressure difference by applying pressure to the surface of the slurry by pumping the slurry into the filter under pressure. The third one is the gravity. A simple method of obtaining a pressure difference is by maintaining a head of slurry above the filter medium. Fourth one is the centrifugal force. The gravitational force can be used successfully in filtration processes. Seeing the effect of viscosity of filtrate, an increase in the viscosity of the filtrate will increase the resistance to flow, so that the flow of filtration is inversely proportional to the viscosity of the fluid. The rate of filtration may be increased by raising the temperature of the liquid, which lowers its viscosity. This may not be practicable if thermolabile materials are involved or if the filtrate is volatile. Dilution is another alternative but may not always be acceptable. An increase in the viscosity of filtrate will increase the resistance to flow, so that the rate of filtration is inversely proportional to the viscosity of the fluid. Seeing the effect of thickness of the filter cake, the filtrate must flow through the filter cake formed onto the filter medium as filtration progresses. Hence, the rate of flow will be inversely proportional to the thickness of the cake. Cake thickness will be affected by area of filtration, so that for a given amount of slurry, increase in area will decrease the cake thickness. Also, in a rotatory filter, the filter cake is removed continuously so that the cake thickness is minimized. Now we will discuss the various theories of filtration. First is given by Poiseuille's equation. Poiseuille considered that filtration is similar to the streamlined flow of liquid under pressure through capillaries. Poiseuille's equation is B is equal to pi delta PR raised to the power 4 upon 8 eta into L, where V is the rate of flow in meter cubes per S, delta P, that is the pressure difference across the filter, R is the radius of the capillary in the filter bed given by M, L is the thickness of filter, and eta is the viscosity of the filtrate. So, Poiseuille's law assumes that the capillary found in the filter are highly irregular and non-uniform. Therefore, if the length of capillary is taken as thickness of bed, a correction factor for the radius is applied so that the rate equation is closely approximated and simplified. Going towards the Darcy's equation, the factors influencing the rate of filtration was given by Darcy's law. Darcy's law correlates the rate factors as dV by dt is equal to Ka delta P upon eta L, where V is the volume of the filtrate, T is the time of filtration, K is constant for the filter media and filter cake, A is the area of filter medium, delta P is the pressure drop across the filter medium and the filter cake, eta is the viscosity of filtrate, and lastly L is the thickness of the cake. Next one is the Kozeny-Kármán equation. Kozeny-Kármán equation is widely used for filtration, which is given by V is equal to A upon eta S square delta P upon KL, epsilon cube upon 1 minus epsilon square, where epsilon is the porosity of the cake, S is specific surface area of the particles comprising cake, which is given by m square upon m cube, K is the Kozeny constant. Limitations of the equation: it does not consider the fact that depth of the granular bed is not same as the actual path transferred by fluid. The actual path is not same throughout the bed, but it is tortuous. Concluding this unit is filtration is a process of separation of solids from a fluid by passing the same through a porous medium known as filter medium. Filter aids are added that help in filtration. Numerous types of filters are available that can be either surface type or depth type of filters. Filtration can be achieved by straining, impingement, entanglement, or by attractive forces. Hope you all enjoyed this informative lecture. Thanks for your attention. Keep studying and goodbye.